Okay. So now what we are going to discuss is something called basis. Okay.
Yes, sir.
Say um, you have two vectors. Okay. Let's
Okay.
say say this is one vector. Okay. And say this is another vector.
Okay.
Okay.
Yes.
Now the question is, say I randomly choose a point in this space, in
Okay.
this xy plane. Okay.
Okay, sir.
Now the question is it possible for you to um, go to this point, okay, or reach construct a vector which is a linear combination of this vector, let me call this vector as v1 and this vector as v2.
Okay, sir.
Okay.
Yes.
By linear combination, so this vector is basically let's say capital V.
Okay, sir.
Okay. So capital V should be equal to some alpha into v1
V1. Yes.
plus beta into v2. Okay.
Yes, sir.
Can you identify this alpha and beta, whether this alpha and beta exist for any arbitrary uh, vector v, capital V?
Yes, sir. We can.
Okay. Okay. So now let me put this question slightly differently. Okay.
Okay, sir.
So this is v2, and now once again some arbitrary point. Now the thing is, you can in this xy plane you can move in only two directions. Okay. Either in the direction along v1 or in the direction along v2.
Okay,
Okay.
sir. Yes.
Now is it possible for you to reach this point, let me call that point p? Is it possible for you to reach that point P where you need to take steps only either along V1 or along V2? Is it possible for you to reach P?
It may or may not. It depends on the position of piece.
It depends on the position of the P. Why?
Because here orientation is important. That is, theta is important. Because if P is along the line of action of vector v1,
Hmm?
then we can reach P.
Okay.
Or else if it is along the line of action of v2, we can reach.
Okay. Uh, Now I'll do a simple one. Okay. Say the vector v1 is along the x direction and v2 is along y direction.
Okay, sir.
Now tell me, is it possible for me to reach P? I should move only either along the x direction or along the y direction. Is it possible for
No,
me
sir.
to reach?
We can.
Why not? So can't I go up to here along the x direction and then can't I go along the y direction so that I could reach P?
Sir. But
Right?
only in one direction.
No, no,
At
no,
a
no,
time,
no.
we have to move in one direction.
Yeah. So
Okay.
you have to either move in this direction or that direction.
Okay.
So it's going to be a combination.
Yes, sir.
So now with this understanding, tell me for the previous problem where this this is v1 and that's v2. Is it possible for us to reach the point P? So this is v1 and that's v2.
Yes, sir. It's possible.
It's possible because so it is same as um, solving this problem,
Yes.
isn't it?
Yes, sir.
So I might have moved some distance along v1, let me call that distance as alpha, and some other distance along v2 which is beta. And now how do you solve it? So you will construct ax is equal to b, where the first column of a is v1 and the second column is v2, and this is alpha beta,
Beta. It is equals to that weight.
that v,
V.
right?
Yes, sir.
So that's what solving this problem. Okay. So
Yes, sir.
once again it's just solving an ax equal to b problem.
Yes, sir.
Okay. Now but still we didn't discuss what is basis.
Basis.
Okay. Now the question is, with these two vectors, is it possible for you to reach any point in this xy plane? Say you can move only along the v1 direction and only along the v2 direction.
No, sir.
Is it possible for
We can't.
we can't reach certain points? Okay. Say for example, for
In
this
third
case,
quadrant.
you mean here?
Yes, sir.
Uh, Say alpha and beta could also be negative, right?
So, but this vector is having direction.
Yeah, but along this direction, but I'm moving in a reverse direction,
We can.
right?
Yes, sir.
So then using v1 and v2, we can reach all the points in this xy plane.
No, sir.
Okay, still there are some points we cannot reach.
Yes, sir.
Could you tell me those points?
On x-axis.
On x-axis. So if there is a point here, then I cannot reach.
Yes, sir.
Okay. Okay, maybe I'll just give a try. Um, Say I move along this direction, okay,
Yes, sir.
up to somewhere, and then in the v2 I'm gonna walk in a reverse direction, okay. So I could go like that, right? And I can reach that point.
Yes, sir.
Yeah, so which means I could reach, I mean, the same manner I could reach any point in the, yeah. And once again, it is same as solving this problem, right? The only thing is this v is going to be some x 0, right? I believe it is, you'll be able to solve that, okay? Right. Now, so the thing is, you will be able to reach any point, okay? You'll be able to reach any point. So if you are able to reach any point, okay, then so those two vectors, okay, the set v1 and v2, okay, those two are vectors with which you can reach the entire R2 space, where the R2 space is like the xy plane.
Yes, sir.
Okay, so for this R2 space, this set of vectors, the minimum set of vectors, okay, is a basis, okay, and this, it's not unique, okay. So you could choose any other v1 and v2, still you can reach, okay.
Yes, sir.
Fine. So that's what the basis vector is, okay. So okay, with this we'll conclude this thing.